Hello everyone, welcome back to our AI Tech Talk live session focused on deep learning. We already have a bunch of questions that I got before the talk, so I will try to cover all of them either one at a time or at the same time. We had a question about what is the difference between AI, machine learning, and deep learning? Where do they all fit in? There was another question about supervised versus unsupervised learning. There was one interesting question about can deep learning build intuition in the machine, which I will try to answer to some extent. And then there was last question was about what approach is better, supervised learning versus unsupervised learning. That to some extent also relates to the data, raw data versus annotated data. So for people who may not know a lot about artificial intelligence and deep learning, let me give you a very quick overview of that. So artificial intelligence is, simply put, a way to make machines to come with intelligent decisions. That is what artificial intelligence is at a very high level. It usually involves tasks that needs some kind of intelligence. That's why it's artificial intelligence. Artificial intelligence could be broken down into expert system or rule-based systems. These were the systems where the rules are very well defined. Or the second big category is machine learning, where the machine is really learning to make decision itself, or it's creating the rules itself. And in machine learning, you have representational learning. And the second big category is deep learning. And deep learning itself could be divided into unsupervised learning and supervised learning. Let's start with deep learning. What is deep learning? So deep learning algorithms have been designed, and it has been inspired by the brain, how collective learning and decision making can be done through these small units of compute called neurons. In our brain, it's biological neurons, and if you are talking about a machine, it's artificial neurons. And when I'm saying it's a machine, it could be a physical software and a hardware machine, or it could be just a software machine itself. So just implementation of a algorithm in a computer. In deep learning, neurons forms the basic computing unit. And the whole idea is that a neuron by itself is not useful, but a collection of these neurons put in a certain hierarchy or a certain array makes it intelligent and generate intelligent results. The beauty of a deep learning algorithm is that it could solve complex problems. The same algorithm could actually solve many, many different kind of complex problems. It's the same as an animal or a human being. An animal becomes intelligent using an organic brain when many of these brains neurons work together, interconnected in a complex array. That array is called layers. And individual neurons, as I said, is not of much use. Usually a multi-layered neural network is called a deep neural network, or simply put, deep learning. When we say deep learning, you have the training phase and after that the inference phase. These two phases are very separate when it comes to supervised learning, and it's a little bit different when it comes to unsupervised learning. Supervised learning is characterized by having a separate training phase. And even before we go into the training phase, it's supervised. You need a supervisor to train the data or to annotate the data so that it could figure out what that data represents. Simply put, you need to know what the features are, and that's the human part of it, where a labor needs to go to tag some of this data, and once the data is tagged, then you train the system to learn some of these rules. And once the training is done, then it's actually went to the inference phase where you can get results. So obviously the limitation of supervised learning is, A, you need a lot of data and you need a lot of trained, tagged data. Second is unsupervised learning. Come to think about it, does a brain work in a much more supervised fashion? Probably sometimes. When we were small, when we were a few weeks old, we didn't really understand much. So we are told to do things. We are said, this is a car or this is a ball. So there is some amount of supervised learning involved. But most of the time, we learn by ourselves. And that's what unsupervised learning is. That is also the best approach to building artificial intelligence system. It's not supervised learning, data-driven approach, which is dominant today in the industry. Instead, it's unsupervised learning, moving from static to dynamic models and more raw data than labeled data. And as you will see, because it's raw data, you don't need annotations. And that is also to some extent why you can think about an unsupervised learning algorithm, unsupervised deep learning algorithm, to have some sort of instincts or intuition. It's similar to how our brains evolved, and some of you have heard about that 5-second rule, that if you're not able to make a decision, you count from 5 to 0, and whatever comes in your mind first, that's 0. That is what you want to do. And that's an intuition part of your brain, where our brain has been evolved since we were very, very small. We learn each time we go out. We learn each time we listen to something or we see something. And all that knowledge is codified into neurons and billions of these. And that's what our brain is. And the intuition or instincts come from the fact that some of these neurons get activated based on some input. Similarly, in an unsupervised learning algorithm, because there is no hard and fast set rules and it has not been trained using a supervisor, it can to some extent provide us intuition to a machine. Okay, let's see. So we covered how can deep learning build intuition in a machine. So just to summarize, the intuition can be built in a machine using some sort of unsupervised learning algorithm. Now the next question is, what approach is better, supervised learning or unsupervised learning? I have covered that to some extent, where I did say unsupervised learning algorithms could do much more. It's easy to some extent to get it up and running once you have modeled the problem correctly. But at the same time, supervised learning algorithms are much more known. They're much more used. There are better libraries available to implement the supervised learning algorithm as opposed to unsupervised learning algorithm. Yes, there are the drawbacks, as I mentioned, that you need a lot of data to train a supervised learning algorithm. It's not just data, it needs to be in a form that's understood by the computer, where the features need to be annotated in advance. I remember one of the quotes from Alan Turning's paper in 1970s. What he mentioned in this paper was that that time, that was 1950s, and he was talking about the law of behavior, where he mentioned that he has set up a computer in Manchester, which is a small program with hundreds or so units of storage, where the machine is supplied with one 16-figure number, and then it replies with another number in 2 seconds. What the interesting part he mentioned was, and it actually still holds true, is that he said that I would defy anyone to learn from these replies sufficient about the program to be able to predict any replies to untried values. So what that essentially means is that you cannot really have a deterministic, or you cannot predict output at a very high level of certainty. So these will still be probabilistic machines, or the conclusion will be probabilistic. The probabilistic aspect is, I would say, what makes unsupervised learning a better algorithm, because ultimately it is a probabilistic model. The reply is still probabilistic. So irrespective of how much data you train a system in using a supervised learning algorithm, the reply will still be probabilistic. And that's where we also want to think about one more thing. If you take a pen and you let it go, it drops. That was the Newton's law of gravity. And that time he tried that with an apple. And actually the first logo of Apple was an apple dropping from a tree. In nature, this law of gravity is there. Now, to model this law in a computer is a much more harder task. And those are some of the things you will need if you're trying to do unsupervised learning, where you're training, and even before that, you're trying to get the data and you need to annotate and tag the data. And some of this data may not actually be correct because it is still simulated. It doesn't include all the information that the real world has. And I actually showed you that an apple, when it's there, and when you leave it there, it just drops. And that's the beauty of unsupervised learning, where the data is much more raw. And on my opinion, it's a better realization of what the real world is. So the output that you get is much more intuitive. It will probably be better compared to a supervised learning algorithm, assuming you are implementing it correctly. And that actually covers all our questions. We will try to cover more of your questions next time. Just as a reminder, we are Skive. We are indeed building machines that feel. We are also hiring anywhere from business, marketing, and engineering. So if you'd like to work for us, please reach out. And have a good day.